In the last class, we looked at PDA, definition of PDA and so on. So for instance, we looked at a PDA for this language, 0 power n, 1 power n. So what were we doing? Every time we get a 0, we are pushing it onto the stack, right? And every time we get a 1, we are popping a 0 from the stack. So at the end of this process, by the time we are done reading the string, if the stack is empty and if we are also in the accept state, then the string is set to be accepted. Okay. So this is an example of a PDA. Then we also looked at the formal description of PDA. This is how you describe a PDA. It's a 6 tuple. You also have a stack alphabet apart from the input alphabet. Okay, this is the additional thing in the PDA, and the table of the transition function looks like this. We will look at an example today also, and formal definition of PDA and formal definition of computation for PDA also we saw. Okay, so let's sorry. So let's look at this language. So consider this example where the language is a power I, b power j, c power k, where I equal to j or I equal to k. You should build a PDA which recognizes this language. So what we mean is that it will accept strings where the number of a's are equal to number of b's, and with c's it doesn't matter, or the number of a's are equal to number of c's, and b's may be different. Okay, number of b's may be different. So either number of a's should be equal to number of b's or number of a's should be equal to number of c's. Only these two kinds of strings will be accepted by this machine. Okay, all three need not be equal. Fine. So can anyone think of the algorithm or logic to build a PDA for this? What to do in 0 power n 1? This is similar to 0 power n 1 power n. The only thing is a third symbol is coming into the picture here. How do you handle that third symbol? That's the only difference. Can anyone give it a try? You can unmute if you want to speak. No one? Okay. Anyway, I need to do my job, so I'll continue. All right. So basically, like 0 power n, 1 power n, what are we doing? We need to compare number of zeros with number of ones. So whenever we are getting a 0, we are pushing it onto the stack. Whenever we are getting a 1, we are popping a 0 from the stack. So this is a kind of matching a 1 with a 0, right? Same thing we will do here also, but here the difference is you cannot cover both the options in one go. For instance, suppose I first push all the a's onto the stack. All right. Now I want to compare them with b's. Then for each b, I pop an a from the stack. If the number of a's are equal to number of b's, this will work well and good. But if the number of a's are not equal to number of b's, but they are equal to number of c's, then what happens? You already popped some a's from the stack because you were matching them with b's. Now you will have a different number of a's compared to the number of c's. Okay. So you are matching with the wrong symbol. All right. Now suppose if the number of a's are actually equal to number of b's, but you are thinking maybe number of a's are equal to number of c's. So what you do? First you push a's onto the stack, then you skip all the b's, and then you match every c with an a. But you are again matching with the wrong symbol. You were supposed to match them with b's while you are matching them with c's. Okay, so we don't know beforehand whether the number of a's are equal to number of b's or number of a's are equal to number of c's. So you have to try both the cases. Okay, so how do you do it? The best thing is we are dealing with a non-deterministic PDA, and we have the advantage of branching out or taking multiple branches with just epsilon transitions and trying out each branch independently, right? So in one branch, I will compare number of a's with number of b's. In another branch, I will compare number of a's with number of c's. even if in one of these branches I reach an accept state, I can accept the entire string, right? So let me draw the PDA. So let me name the first state as say 1. And this is also an accept state because you see ijk can be greater than or equal to 0, which means empty string is also a part of this language, right? Which means the start state is an accept state. Okay, so I'm in the first state, and any PDA, before we start, what do? We first push a dollar, right? So you read nothing, you pop nothing, you just push a dollar onto the stack. And you reach the second state. So this is where the real algorithm starts. So here, what we do, every time we get an A, we just push it onto the stack. We pop nothing, we just push this A onto the stack. Okay. Now I need to take 2 branches. Okay, just epsilon transitions, 2 branches. In one branch, I will check whether the number of B's are equal to number of A's, and in the other branch, I will check whether the number of C's are equal to number of A's. Okay, so let me branch out to 2 different branches. So here it is an epsilon transition. You're reading nothing, and also you are popping nothing from the stack, and also you are pushing nothing onto the stack. Okay, so this is how you write epsilon transitions in a PDA. Everything is epsilon, all the 3 symbols. Similarly, I am branching out, taking another branch. Okay, and here say I'm reaching state 3. So in this branch, I'm comparing number of A's with number of B's. Okay, so here every time I get a B, now this is similar to 0 power n, 1 power n. Every time I get a B, I pop an A. I push nothing. Okay, so for every B, there is an A that is being popped out. If the number of B's and number of A's are equal, you will hit the dollar symbol at some point. All right, so you just pop that dollar symbol, and you reach the final state. But it is not over yet. There are still C's remaining. There are some C's that may come later, right? So you need to handle them as well. The input string you should read completely. Just because you reach the final state and the stack is empty, it's not sufficient. There are 3 conditions, like I said. All 3 conditions need to be satisfied. The input string should also be empty. So you may get C's, but there is nothing for you to do. If you see a C, you just skip it. You don't change the stack. So you pop nothing from the stack and you push nothing onto the stack. All right. So once the entire string is done, you are in the final state. Anyway, the string will be accepted. Okay. So this branch compares number of B's with number of A's. Now let's go to another branch which compares number of C's with number of A's. So let's say this state is number 5. Here, before I compare number of C's with number of A's, I will get B's in between, right? I can't change the order. So I need to read them, but there is nothing for me to do. I just skip them, right? I'll just skip the B's. And the moment I get a C, I pop an A from the stack and I go to the next state. Okay. And I'll continue the same thing in this state as well. Every time I see a C, I'll pop an A from the stack. And once all the C's are done, there will be a dollar on top of the stack. I just need to pop this dollar. Okay. And I reach the final state. All right. So done. So if you reach the accept state either in this branch or in this branch, anything is fine. You just accept the overall string. Okay. Any doubts so far? No doubts? All right. Then let's Yeah, any doubt? Okay, so let's call this PDA, say PDA2. This is the second example. So let's give the formal description of PDA2. Okay, so like I said, PDA is a 6 tuple: Q, sigma, gamma, delta, Q naught, and F. So let's list each of them. What are the set of states here? 1 to 7, right? So one, 2, 3, 4, 5, 6, 7. Okay, and what is sigma? What is sigma? Can anyone tell me? What is the input alphabet for this PDA?
ABC.
Yeah, that's all, ABC. You just need to look at the language to know sigma. So all the strings are made up of only A's, B's, and C's, nothing else. Some A's followed by some B's followed by some C's. So sigma is ABC. What about gamma? The stack alphabet?
$A.
Exactly. A and dollar. So these are the only two symbols that we are pushing onto the stack. First, we are pushing a dollar, and then every time we see an A, we are pushing it onto the stack. We are not pushing B's and C's onto the stack. We see a B, we are popping an A. We see a C, we are popping an A. That's all. We are not pushing B or C onto the stack. Only A and dollar are being pushed onto the stack. So the stack alphabet is just A and dollar. Okay. And 1 is the start state, and F is 1, 4, 7. Okay. And delta. So let me once mention the definition again. It is Q cross sigma subscript epsilon cross gamma subscript epsilon mapping to power set of Q cross gamma subscript epsilon. Okay, but this is only the description of the transition function, not the actual details of the transition function. So we need to write all the details of the transition function, that is in the form of a table. Okay, so this table will have input here, the symbols from the input string, and the symbols on top of the stack. Okay, and then all the states are listed here: 1, 2, 3, 4, 5, 6, and 7. Okay, now what are the input symbols? Input symbols are nothing but coming from sigma, right? So A, B, C, and apart from that, epsilon also. Okay, so we need to take all the 4 possibilities: A, B, C, and epsilon. Okay, now for each of the input symbols, the top of the stack can have multiple possibilities. The top of the stack can be either A or dollar or epsilon, right? Similarly for B, again 3 possibilities: A or dollar or epsilon. Again for C, it is either A or dollar or epsilon. Same thing for epsilon as well: A or dollar or epsilon. Okay, so now we need to fill the table. So when the input is 1A or 1A epsilon, whatever is the case, so let's see. We need to look at the diagram and fill the table. So a simple way to fill the table is, if you understand the definition of dollar. So, okay, so what we will do, you see, these three things form the input. In any transition, there are symbols before the arrow and there are symbols after the arrow. So the symbols before the arrow form the input, the symbols after the arrow form the output. Okay, so this is the input, this is the output for delta function. So for this particular example, how do we write? Delta 1 epsilon epsilon in the same order, 1 epsilon epsilon. For this input, the output is, you're going to state 2 and you're replacing this epsilon with this dollar. Okay, 2 comma dollar is the output. 2 comma dollar. In this case, there is only one tuple. In some cases, there may be more than one tuple, but whatever is the case, you should put the output in set brackets. Okay. Actually, we will see in this case, there is more than one tuple. You see, for the same input, 2 epsilon epsilon, here also same input, 2 epsilon epsilon, the outputs are different. So in this case, this set will have two tuples. We will see that. So first, let's start with this 1 epsilon epsilon. For this input, the output is 2 comma dollar. So for 1 epsilon epsilon, the output is $2 comma dollar. Okay, you should put in set notation. And when you are in state 2, when the input is A epsilon, the output is A and 2. It's coming back to 2. Okay, 2A, that is the output. Okay, for 2A epsilon, the output is 2A. For 2A epsilon, the output is 2A. Okay, now for 2 epsilon epsilon, in one branch you are going to 3 epsilon. But for the same input again, for 2 epsilon epsilon, in another branch you are going to 5 epsilon. Okay, so you're having two outputs, 3 epsilon and 5 epsilon for the same input, 2 epsilon epsilon. Okay, so here is an example of a set with two tuples. For 2 epsilon epsilon, you are having two tuples. You are going to state 3 and pushing epsilon onto the stack, as well as you are going to state 5 and pushing epsilon onto the stack. Got it? So this is why we need set notation. And then for state 3, when the input is B and top of the stack is A, you pop A and you push epsilon and you go to state 3. So for the input 3BA, the output is 3 epsilon. So for the input 3BA, the output is 3 epsilon. Okay. Now for the input 3 epsilon dollar, the output is 4 epsilon. For the input 3 epsilon dollar, the output is 4 epsilon. Okay. And for the input 4C epsilon, the output is 4 epsilon. For the input 4C epsilon, the output is 4 epsilon. Right? Now coming to 5. For the input 5B epsilon, the output is 5 epsilon. For the input 5B epsilon, the output is 5 epsilon. And for 6, there is one more. Yeah, for the input 5CA, the output is 6 epsilon. Okay, for the input 5CA, 5CA, the output is 6 epsilon. Now for state 6, for input 6CA, the output is 6 epsilon. For input 6CA, the output is again 6 epsilon. And again 6 for the input 6 epsilon dollar, the output is 7 epsilon. For 6 epsilon dollar, the output is 7 epsilon. That's it. For 7, there are no outgoing transitions, so nothing else. So these empty cells, they are basically filled with 5s. Okay, so you need to understand that the empty cells are filled with 5 or null set. Okay, so this is how you fill the table. Any doubts so far? All right. So yeah. So let's move on to the next example then. Okay, so this is the example. Given the language W and WR, where W belongs to 0, 1 whole star, where WR indicates the reverse of W. Build a PDA which recognizes this language. So basically, this is a palindrome. All right. So you are asked to build a PDA to recognize an even length palindrome. There are also odd length palindromes, but here we are only looking at even length palindrome, W and W reverse. So first half is W, the second half is the reverse of the first half. So think of a PDA or how to build a PDA for that. Or think of an algorithm. How would you solve this problem if you are given this problem? You are allowed to use stack. How will you solve it? Anyone?
Sir, you could have a different symbol when you encounter a 0 and a different symbol when you encounter a 1, and then
Okay.
push it off the stack or pop it off the stack when you encounter it after the first half of the string.
Yeah, but how do you know you reach the first half of the string? You are looking at only one symbol at a time. You don't know the total length of the string.
Sir, can we use 2 stacks to make a queue kind of thing?
Sorry?
2 stacks to make a queue, and then we push, no, pop from 2 ends, then we check.
No, basically, whether you are using a stack or a queue, the important thing is you need to know the half of the string. Even using 2 stacks to implement it in the form of a queue, that will not work for this example. Even there, you need to know when you reach the midpoint of the string, right?
Yes.
Yeah. One clue is we are dealing with non-deterministic PDA, so there is an advantage. So can someone think along those lines? Can you use non-determinism here to solve this problem? So forget program, come back to PDA. So
we can have two in a union, whether one recognize the string when we start from the start to end and other recognize it from end to start. If they both recognize this string, then they will be palindromes.
No, it's not just recognizing, right? It's like you should compare the first half with the second half. It's not just reading from beginning to end and reading from end to beginning. You should compare these two.
Mm-hmm.
I'm
Okay, sir.
not exactly sure how to implement this, but as we keep reading the string, we assume we are at the middle and we keep checking it with the stack.
Mm.
If it's the same, then we have two branches where one it assumes it's the middle and the other it keeps taking more input.
Exactly, exactly. Yes. Yeah, that's the right answer. So non-determinism, again, like I said, we don't know when we reach the midpoint of the string, right? But so there are two options. Either I reach the midpoint or I did not reach the midpoint. I can test both the options. If I actually reach the midpoint, then that branch will reach the accept state, right? If I don't reach the midpoint, then I will wait until I reach the midpoint. That branch will reach the accept state later. Okay, so you need to use non-determinism here. So the PDA looks something like this. So let's call this PDA 3. So this is also the start state is also a final state because this is 0, 1 whole star, which means empty string is also accepted because that will also satisfy this condition. That will neither have first half nor second half. Entire thing is empty. Okay, and we first push dollar onto the stack. And so here what we do. Okay, first let me give you examples. For instance, suppose I have say 0, 0, 1, 1. Sorry, not 0, 0, 1, 1. 0, 1, 1, 0. This is the correct example, right? So this half is reversed and you get this half. So this is my W. This is my W reverse. Or some example like say 1, 0, 1, 1, 0, 1. So this is my W. This is my W reverse. Okay. So what you do, the first half, whatever symbols you get, you push them onto the stack. So first I get a 0, then I push a 1 onto the stack. And then the second half, whatever symbol I get, if that symbol is matching with the top of the stack, I pop that symbol. Okay, otherwise I reject. So 0, 1, 1, 0. Now the symbol is here. Now the read write head is here. I see a 1. I pop this 1 from the stack. Okay, then the read write head is here. I see a 0. Then I pop this 0 from the stack. Done. Now I reach the end of the string and the stack is also empty. And I should be in the accept state. And that's it. I'll accept the string. Okay. Similarly for 101. First I push this 101 onto the stack. Then for this one, I pop this one. For this 0, I pop this 0. For this one, I pop this one. Okay. That's it. So in Q2, assuming I am dealing with the first half of the stack, whatever symbol I am getting, I am just pushing it onto the stack. So if I get a 0, I push 0 onto the stack. There is nothing to pop. If I get a 1, I push 1 onto the stack. Okay. But I don't know how many symbols I should keep pushing. I don't know when I reach the middle of the string. So at the same time, I will also branch out with an epsilon transition to Q3, where in Q3, I assume that I am in the second half of the string. Okay, Q2 means I am in the first half of the string. So I will only keep pushing symbols. Q3 means I am in the second half of the string. So every time I see a symbol in the second half, I pop it from the stack. I pop the same symbol from the stack. So if I see a 0 in the second half of the string, I will assume if there is a 0 on top of the stack, I will pop it. If there is no 0 on top of the stack, I will not specify it. So it will automatically understand it is undefined. It will not know what to do. It will just reject that case. It will just reject that string because it is not finding that case. Okay. So only if I get a 0, I pop 0 from the stack. And if I get a 1, I pop 1 from the stack. I will not give the cases where I am reading a 0 and 1 is on top of the stack, or I am reading a 1 and 0 is on top of the stack. I need not specify. That is as good as saying reject those cases. If I see a 0 and 1 is on top of the stack, reject it. If I see a 1 and 0 is on top of the stack, reject it. So the way of rejecting is by not specifying that. Okay, so only whatever cases you specify, it will handle them. All other cases, it will reject. Okay, and finally, it sees a dollar on top of the stack and it pops it. Okay, and it reaches the final state. All right. Any doubts? Is it clear or should I explain again?
So once again.
Okay, so what I'm saying is, you see, like if I take this string 101 101, okay, 101 101. Ideally, I should push only these three onto the stack, and when I am reading these three, I should pop one symbol from one symbol at a time from this these three on the stack, right? So first I'm getting, say first I'm reading 1, I'm pushing 1 on the stack. Then I read a 0, I push this 0 onto the stack. Then I read a 1, I push this 1 onto the stack. Okay, now I'm reading 101. I'm reading a 1 and 1 is on top of the stack. I pop it. Now I read a 0 and 0 is on top of the stack. I pop it. Now I read a 1 and 1 is on top of the stack. I pop it. Okay, so by the time I am reading the entire string, you will see a dollar. That's okay. You will anyway pop that. The stack will be empty. Fine. This is fine because you are sort of pushing only the first half symbols onto the stack and reading only the second half symbols from the stack and popping the first half symbols. But how do you know this is the first half? I may also mistake thinking that, okay, the moment I see a 1, it may be just 1 1, my string may be just 1 1. I don't know what I'm going to get in the later part of the string, right? Then I should just push this, and the moment I see a 1, I should pop it. But if I do that, what if there are more symbols in the string, 1 1 and then 0 0 1 1? Okay, so I don't know at which point I should stop pushing and at which point I should start popping. Okay, so what I should do at every point, every time I read a symbol, I will try both the cases. I'm seeing a 1. What if this is the first half and I have only one more symbol in my second half? Okay, so I just push this 1 and the moment I see a 1, I pop this 1. Done. But what if this is not my half? Then what should I do? So this is one branch where I'm pushing a 1 and I'm popping a 1. I will take another branch where I am pushing a 1. Now I'm seeing one more 1. Okay. Now again here I have two options. This may be the half point or midpoint, or this may not be the midpoint. If it is the midpoint, for the next 0 0 I see, I'm seeing 1 on top. So I will just reject it. Okay, because the symbol I'm reading next and the symbol on top should be same. If it is not the midpoint, I will push the next symbol. So I will increase it to 1 1 0. Now again I have two options. What if this is the midpoint and what if this is not the midpoint? If this is the midpoint, then I see a 0. I pop this 0 from the stack. Then I see a 1. I pop this 1 from the stack. And I see a 1. I pop this 1 from the stack. But if this is not the midpoint, I add this next 0 also onto the stack. Okay, then it will become 1 1 0 0. But in this particular case, this branch will end up in accept state. This branch will not end up in accept state. Okay, so at every step, you assume both the conditions. You are at the midpoint, you are not at the midpoint. Assuming both these conditions, you do both the things. You push the next symbol thinking you are not at the midpoint, or you pop the current symbol thinking you are at the midpoint. In one of these branches, if you keep continuing, one of these branches lands up in the accept state if the string is a valid string. Otherwise, no branch will end up in an accept state. Okay, is it clear now? Or still
Sir, I didn't understand the diagram.
You didn't understand diagram? Okay.
Q3.
Yeah, so this Q2, as you, like I said, give meaning to each state, right? The meaning of Q2 is you are still in the first half. Okay, if you are in the first half of the string, what do? Whatever symbols you are getting, you just push it onto the stack, right? So if you are getting a 0, you push 0 onto the stack. If you are getting a 1, you push 1 onto the stack. This much you understood?
Yes.
Okay, now normally what should we do? If I know the exact midpoint, only then I should start popping. Okay, but I don't know the exact midpoint. So what I do, I take an epsilon transition from Q2. So I take both the options from Q2. So when I'm in Q2, I will take both the options. I will assume the string is at the midpoint. I will also assume it is not at the midpoint. Okay. If it is at the midpoint, I will take the epsilon transition. If it is not at the midpoint, I will keep pushing the symbols again and again onto the stack. Okay. So this epsilon transition is saying, maybe now I reach the midpoint, go to Q3 and check it. If it is not the midpoint, that branch will be anyway rejected. Again, I push one more symbol. Again, I will check. Maybe I'm at the midpoint. Go to Q3 and check it. If it is not at the midpoint, that will be rejected. Again, I will push one more symbol and again I will check. Maybe I'm at the midpoint. I will go to Q3 and check. If it is at the midpoint, then every time you read a symbol in the second half, you will pop a symbol from the first half. Finally, the stack will be empty and you will reach the accept state. Okay. So Q2 is referring to the first half of the string. Q3 is referring to the second half of the string. When you're reading the first half, you just push those symbols onto the stack. When you are reading the second half, you pop the previous symbols which are already pushed onto the stack. If the next symbol you are reading is matching with the top symbol of the stack. Okay?
Yes.
Yeah. Okay. All right. So let me give you the process tree for one example for this machine. Okay. So, sorry. So process tree of, say, input 0, 0, 1, 1. Okay. So again, so let me copy the machine for reference in the next page. Okay, so this is the machine. So initially, say I am in Q1 and the stack is empty, right? So what do? I first push a dollar onto the stack and I go to Q2. Now, when I am in Q2, I have two options. Either I read the next symbol or I assume I am at the midpoint, right? What if the string is empty? That can also be an option, right? So I need to test both the cases. So one option is I assume I'm at the midpoint. Another option is I am reading, I am looking at the first half of the string. Okay. So if I assume it is epsilon, I directly come to Q3, right? So basically in epsilon, when I'm reading epsilon, I am neither popping nor pushing anything onto the stack. So the stack will remain same and the state will be Q3, right? So the stack will remain the same and I'll come to state Q3. All right. Now again in Q3, I have two options. Either I take an epsilon transition or I read the next symbol. Okay. So I take epsilon transition or I read the next symbol. In this case, the symbol is still first 0 only, right? Here in this branch, you haven't read any symbol. So you are still at the first letter. Okay. Now, if you take epsilon transition, you are popping the dollar from the stack. So you are making the stack empty and you are going to Q4. So you are popping dollar from the stack. You are making the stack empty and you are going to Q4. Now in Q4, nothing else is defined. There is no outgoing transition, right? So there is nothing else that you can do. So you cannot go further. So this branch will be rejected, but still you have string 0011, right? You still have 0011 with you. This string is not empty. So this branch will be rejected basically. All right. So rather than writing it here, make it easy to read. So I just write it here. You will reach a dead end because your string is still not completely read. Okay. Now you are in Q3 and you are reading the next symbol 0011. Okay. You are in Q3, you are reading 0, but is 0 on top of the stack? No, the stack has only dollar on top. So it is not matching, right? So it will not know what to do. So this branch will also die out. Now let's take this branch. You are in Q2 and you are reading a 0. You are in Q2, you are reading a 0, you are pushing that 0 onto the stack and you are coming back to Q2. So this stack, you are pushing a 0 onto the stack. So you take this, you have a dollar already. Now you push a 0 onto the stack and you are coming back to Q2, right? And now again, you have two options. Either you take the epsilon transition or you assume you're still in the first half and you read the next symbol. Next symbol is also a 0. Okay. So let's take this branch. If you take an epsilon transition, what is happening? You are doing nothing. You are pushing or you're neither pushing nor popping anything onto the stack. You're just going to Q3. Okay. So the stack will remain the same and you will go to Q3. The stack will remain the same. And you are going to Q3. Now in Q3, again, you have two options. Either you read a 0 and pop it from the stack, or you take an epsilon transition and pop the dollar from the stack. Okay. This page is not enough, so let me increase its size. Okay, I'll look at it later. So at least I got the length. Okay, so now you are in Q3 and this is the stack. You have two options. You either take an epsilon transition or you are anyway. No, now you are still at the first symbol. You see, here you are at the first symbol. You pushed it onto the stack. You still did not read anything, which means you are still the first symbol only. Okay. So if you are at the first symbol, if 0 is on top of the stack, then just a minute. Sorry. You are at the second symbol, not the first symbol. Yeah, you read the first symbol here and you came here. You will move on to the second symbol. Okay. Now 0 is on top of the stack. Okay, first let's look at the epsilon thing. In epsilon transition, dollar should be on top of the stack so that you can pop it. But dollar is not on top of the stack, so there is nothing for you to do. So this branch will die out. Okay, when you see 0 on top of the stack, what do? If you see 0 on top of the, if you are reading a 0 and if you see 0 on top of the stack, you pop it. Okay, so that is possible here. So you pop this 0 and you will be left with dollar and you come back to Q3 only. Okay, so the stack will be updated to only dollar. So you pop this 0, you are left with a dollar. Now again, you have two options. Either you take the epsilon. Okay, you are coming back to Q3. Either you take the epsilon transition or you go to the next symbol 1 0 0 1 1. You come here in epsilon transition. Yes, you pop the dollar and go to Q4. Yes, you pop the dollar, the stack became empty. You go to Q4, but in Q4, you are not given any outgoing transition. So the string should have been empty by now, but the string is not empty. You are at the third symbol. 0, 1, 1. Okay, but the string is not empty, so you don't know what to do. So this branch will die out. Okay, here you are at the third symbol. If you read a 1 and if 1 is on top of the stack, then you pop it. But is 1 on top of the stack here? No, dollar is on top of the stack. So there is nothing you can do. You have to reject this branch as well. Right? So now let's continue with this branch. You are in Q2, you pushed a 0. Now you are seeing next 0. What do? If you are in Q2 and you see a 0, you again push it onto the stack and you come back to Q2. So this will be updated to $0, 0, and you come back to Q2. Now again you have two options. Either you take an epsilon transition or you read the next symbol. What is the next symbol? 1. Okay. So if you are taking an epsilon transition, you are doing nothing. You are taking the stack as it is and going to Q3. Okay. So you are taking the stack as it is. That is $0, 0, and you are going to Q3. Now again here you have two options, either epsilon transition or go to the next symbol. So that next symbol is 1. Okay. So if you are in epsilon transition, you should see $, on top, but there is no $, on top. So this branch will die out. Okay. And if you are seeing a 1, if you are reading a 1, then 1 should be on top of the stack, but here 1 is also not on top of the stack. So this branch will also die out. Okay. So now again, you should come back to this branch. Here, if you are seeing a 1, what do? You are in Q2, you are seeing a 1. If you are in Q2, whatever symbol you are seeing, you just push it onto the stack, right? So let me make more space. Okay. So now you push a 1 onto the stack. That is $0, 0, 1, and you come back to Q2. Now again you have two options. Either you take epsilon transition or you read the next symbol, that is the last one. Okay. If you take an epsilon transition, you will keep this stack as it is and go to Q3. Okay. So you will keep this stack as it is and go to Q3. Now in Q3 you have two options, epsilon transition or read the next symbol. The next symbol is the last one. Transition $, should be on top of the stack, but $, is not on top of the stack, so this branch will die out. In if you're reading the next symbol, if it is same as the top of the stack, you will pop it. In this case, both are same, so you will pop this one. All right, so you will get $, 0, 0, and you will come back to Q3. Now again you have two options, epsilon transition or next symbol. There is no next symbol. You already reached the end of the string. Okay. If it is epsilon transition, $, should be on top of the stack, but that is not the case. So this branch will die out. If now you reach the end of the stack, but are you in the final state? No, right? You reach the end of the stack, but you are still in Q3 and the stack is also not empty. So this branch will also be rejected. Okay. Now again, we need to proceed with this branch. So here, what do? I see a 1. If I'm in Q2, whatever symbol I'm seeing, I'll just push it on top of the stack. So I'll push this one also on top of the stack. Okay. So let me make more space. So I see this. I push this one also onto the stack. Okay. So it will become $, 0, 0, 1, 1. Right? And I'm back in Q2. Now again, I have two options, either epsilon transition or I read the next symbol. Next symbol is nothing but end of the string. If I'm in epsilon transition, I will give this. Okay, let me draw it a little spaciously. So either I am in epsilon transition, or I will read the next symbol, that is nothing but the end of the string. If I'm in epsilon transition, I will copy this as it is, and I will go to Q3. Okay, so this is Q3. Now again, I have two options: epsilon transition or reach the end of the string. Epsilon transition should have dollar on top. It doesn't have dollar on top, so this branch will be rejected. I reach the end of the string and the stack is not empty, and I am also not in the final state, so this branch will also be rejected. Okay. Now in Q2, I already reached the end of the string. The stack is not empty, and also I am not in the final state, so this branch will also be rejected. Okay. So basically, every branch here will be rejected because this is not a valid string. 0011 is not a palindrome, right? So this is just an example for you to understand what is happening at each step. All right. We will later look at an example of a proper string. Okay. And we will see an accepting branch. Okay. So for now, this string will be rejected because all the branches are ending in a reject state. No branch is ending in the accept state when the stack is empty and you are done reading the string. Okay, so all these branches are rejected. Any doubts so far?
No, sir.
Yeah. Okay, so let me just mention that why this will be rejected. Not a single path leads to the accept state by the time the string is read completely. Hence, the string 0011 is rejected by PDA 3. Okay, so yeah, so that's the example. We will look at a valid example of a string which will be accepted by this machine in the next class. All right, so let's stop here. Okay.